All right, everybody. We have the Emergency Personnel Rover, or EPR. My name is Mason Carnino. This is Jonathan, Farah, Dennis, and Alan. Basically, we're going to give you a brief overview, and we'll go through a couple of components and possibly give you a live demo if we have the time. So the concept is we wanted to build a rover that would be autonomous. Eventually, most teams that say autonomous, now we're just doing object avoidance, pretty much. It was getting there where we almost were that close to implementing our flood flow algorithm, which would allow it to go from point A to point B on its own, deciding whatever kind of path or direction we want it to do, whether it needs to go to every single cell or if it needs to just go as fast as it can to that. And what it's going to do, though, is it's going to help emergency response teams in emergency relief efforts. What that's going to be is like earthquakes, tornadoes, anything where the structural integrity is weak or they're unsure of it. They can send in this rover instead of firefighter John or Jim or whatever their name is. And it will actually go around, look for human body temperature, ambient skin temperature. When it does find that, it will relay that back to the emergency response team, as well as with a 2D map of the surrounding area. Eventually, it would be 3D. That way, they can actually visually see what is in the room. That way, they can choose the best course of action to go and save this person that's stuck in there. Whether it be, go through the roof, is there a hole in the wall somewhere, is the door wide open, can they just walk right in? But this also allows the emergency response teams to free up manpower resources elsewhere and to possibly keep their lives safe as well as the victims. Let's see what's next. Oh, so the inspiration for the project, okay, we'll get to this, but the original one is Incredibles. I don't know if you guys have all seen Incredibles. When he dives off the waterfall, he goes into the cave, and I was thinking about this, and the bad guy, I forgot his name, but he throws down that little flying thing, goes down, it's searching, he hides behind the skeleton. I wanted to do something like that, and we were thinking of originally doing an aerial drone, but we thought, in this scenario, there's going to be hanging wires, there might be busted pipes, things that it might run into, so we eventually went with the rover, and it was right when the Mexico earthquakes were happening. And so we thought, it would be a great idea to help the emergency response teams in those situations where they can go in and expedite and make their search efforts more efficient. So more efficient, sensor precision, and decreased search times. And they can use multiple of these as well. So some design goals that we have, we wanted to make sure that the sensors were going to be able to work together. Unfortunately, we'll get in discussion with that a little bit more, but they would map the room as well as give ambient temperature. And when it did find a body temperature, instead of mapping the room black in that specific direction, the mapping would be red or green, something to indicate that there is a person in this direction. For the rover itself, we wanted to make it so it would be able to traverse over difficult terrain, whether that be knocked over computers, dead bodies, I'm just kidding, it's terrible to say, but rocks, anything that it needs to, and with more money we would. It is pretty small. We do have a video of it climbing stairs that we'll show you guys later, but the wheels aren't big enough to really go over anything major. So here's some of the initial specs, and I'll let our team start. Oh, never mind, I'm taking over this one first. Originally we wanted a 3D print, and this is what it was going to look like. Turns out that's really expensive. It's like $800 just to do the printing for that. So we decided to go with PVC pipe. Saved about $780. So yeah.
Alright, so for our design, we're using 6 motors on our rover, and we have them all being able to control them bi-directional, which means they can all go forward and backwards. And we use that to turn the rover around really easily. Our motors are also spec'd for 6 volts, 133 RPM. They can go really fast, but for our purposes, we keep it kind of slow. Alright, so how to do the bidirectional control? We need to do use H-bridge technology. So as you can see there, it's an H, and if you connect one of the paths of wires, it goes counterclockwise, but if you do the other way, it can go clockwise. Nice. So at first, we wanted to use the L298N motor driver. It's integrated on a small circuit. It's super cheap. and it's specially made for motor control.
So when we were looking for thermal sensors, we had two options available to us when we were looking at either this model, which is the Omron D6T, that had roughly, I think, a 4-foot viewing range, about reading temperatures, and about 15-degree angle. And the other option was, I think, a $250 thermal sensor that had a viewing range of about 5 degrees, but had a range of like, I think, close to 50 feet. We went with the cheaper one just because we wanted to have something that had a better viewing angle, and since the thermal sensor was going to be used inside buildings and hallways and such like that, that we didn't need that far of a range for thermostat as well, so the cheaper one made the most sense. This also allows us to have some degree of a fall, so that in case that, let's say body temperature isn't exactly 32.5, it's maybe like 33 or 31, we can have this range of like mistakes just in case to allow rescuers to know like the possibility of somebody being in a certain area, like not past a wall or past a doorway or just like by reading the heat signatures.
Okay, so we started off using the LiDAR V3 Lite. It's an optical distance reader. It has a maximum range of 40 meters, but then we chose this because it was an inexpensive LiDAR, and then we wanted to use our own stepper motor to do a 360 scan. And then so hector mapping is a software in ROS. This is not our demo, this is what our goal was, to do a 360 with the LiDAR V3 and get a mapping of the unexplored environment.
So as you can see there, he like mapped the hallway and then went back into a room and mapped that with the LiDAR.
Okay, so for the Wi-Fi, we used two types of Wi-Fi, which is called ESP8266. There's two types. It's the 01 and the Node MCU. We were able to transfer temperature over time through the Node MCU, but the only issue we had that the website we used to gather information doesn't update frequently. If we had like more time, we would done our own website to gather information.
All right, guys, we're going to go through some problems and solutions. So with our thermal, something that became difficult and is an issue is it's a 4x4 reading cell, block cells, and it averages in each cell. So the further the person gets away, the lower the temperature is reading because it's reading the ambient temperature around them as well. That's why we were saying we're going to give it we did give it a error correction of about 3 to 4 degrees. In our perfect scenario, we'd grab sick people with fevers in a refrigerator, just so we can clearly tell who's what, or have a fire going on somewhere. And then as well, it took us a couple months to figure out the wire harness. They did not manufacture it anymore. We could order it off to the side, but it said it'd take 4 months to get it. And so we eventually decided to solder it. It's the teeniest little piece of component, and the solder would keep breaking. Eventually we took it to Jimmy in electrical engineering. He soldered it. It's worked ever since, and we'll show you guys a demo of that later. With the power supply and motors, we were noticing that we didn't have enough, we had the voltage, but we didn't have enough current. So we actually broke down one of his old RC car batteries and are now using that for our actual driving.
All right, so another problem we're having with our motor drivers was overheating. They weren't rated properly for the amps that we were drawing, so we upgraded to these ones that are shown here, which are rated up to 30 amps, and we haven't had problems ever since.
So for the LiDAR V3, we're having problems getting the laser scan to map on ROS, the hector mapping part, but we're lucky enough to borrow the RP LiDAR, which is a more expensive LiDAR. It has a built-in motor, and then it like does a mapping without ROS, but using ROS, it can do hector mapping.
So here's the original design that we went off of for the PVC pipe sort of design, and here it is. I like to think that ours looks a little prettier with our chrome rims. And then here's just a quick circuit breakdown of our motors. They're all in parallel, so they're all getting the same voltage, but of course they're going to be drawing the current that they need individually. And then some results of discussion. So we're going to start showing some demos.
This is a simple one. The rover's going down some stairs. As you can see, you know, the wheels just stop it. Not tipping over or anything. You know,
Okay,
it's got
the
a nice
reason you
wide
hear us
base.
yell at the end is we could not get it to work for months, and one day it just started working, and we were so stoked. Oh yeah, no, let's keep this out. Yeah.
Alright. Here's,
All right, don't curb your excitement
another
too
test.
early. We've got even more videos to show you. Here we go.
You're welcome.
Just one sec.
We tried it on stairs, but unfortunately all the stairs in the surrounding area are inverted a little bit, and so after you get past the first step, it kind of messes it up.
Yeah.
All right, so like I said, autonomous, obstacle avoidance. We do have 3 ultrasonic sensors that we eventually went to. We were going to utilize our old LiDAR and rotate it back and forth. However, it was taking too long. So if it saw something in front of it, or if it didn't see something in front of it, by the time it got back to it, you know, we could already be hitting a wall. So we decided to buy really cheap ultrasonic sensors, as you saw earlier in someone else's PowerPoint. They're around $3 each. Set them up. We got the front working, as this video you'll see. Yeah, okay. But basically, the left one's working as well. The right one, however, will work one reading. The next reading, though, it just gives out a random number. So when we did start running it, it would just do donuts. It would literally just turn left constantly, thinking there was a wall to the right of it. And so when we do have the demo today, it's just going to be the basic obstacle avoidance in front.
Okay, so this is before we got a hold of the RP LiDAR, the more expensive one. So we use processing to map out like some kind of visualization of if there's something in front of the LiDAR. So in the video, I put like a box, and then the lines get shorter, or if I move the box away, the lines get longer. And I hard-coded an angle to for the stepper motor. And then
We ended up not using that,
Yeah.
and we got to this, which is the RP LiDAR, the 360 one.
Yeah.
I think I can. So, you guys-
one is the screen recording of the actual laptop, and then we have a recording of the thing from behind. And then this is the computer science building, first floor hallway.
You guys might be able to recognize, here's the elevator, men's bathroom for you ladies, there's a ladies' bathroom.
And then you can see these black dots in the hallway, that's us behind it following it, which is a problem. Because the LiDAR needs a laptop, and then we didn't want the laptop to be on the rover.
Yes.
Don't mind my messy office. So this is the thermal sensor.
Checking all the cells. If you notice someone, you'll notice the green light will turn on. As I step closer, it's starting to notice me. A little bit more steady now. It's going to keep it on.
So
Now,
basically,
just to show, you finally get out of the way. Hey, turned off. Hand in front. Hand in front.
okay. So basically what's happening is I averaged out the cells. I created an algorithm that instead of, you know, seeing if one cell has it, it just says in general, is there a person in our field of view? Yes or no, turn on the light. And then the eventual application that we would do, since we're now using the 360 LiDAR, would be to implement with the stepper motor. It will know what degree that it's reading the person at, turn the rover towards that, and drive it to the person, just for our simplistic, I guess, viewing, instead of actually setting that over Wi-Fi. And then here's a breakdown of our costs. It's not completely accurate because we did not purchase this. We did borrow it from the computer engineering department. However, it is the most expensive item. Our LiDAR instead was about $150, $160, and we ended up, I think our budget was $850. We ended up about $100, $150 below. And basically, in conclusion, nothing went as planned. I think we all probably learned that. It really makes you appreciate systems engineering or any sort of thought process of a life cycle of whatever components you're working with. You know, we came in with unrealistic ideas that are great, but in reality, you have to sit there and go, what components are going to work with what? Do they all mesh together? And it would have saved a lot of time and effort. But basically, future things that we can do with it is attach it to drones. The big one that we want to do is find missing hikers. Questions? Sherman? Good?
Questions for the team? No? So,
I don't think we have time to do that. All right, somehow, some way, I think it's reading upward. But basically, as you saw when I put it in front, it does a U-turn and then it keeps going forward. Thank you, guys.